Hello, 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 hello. Welcome again to this episode of This Dev Life. Yeah, you remember that face by my side? His name is Elijah Oyekunle. We had him on the last episode on This Dev Life where we talked about his life, daily life as a developer. So it needs no introduction. If you missed that episode, of course, go back and listen to it. I'll drop the card. If it's a video you're watching, you see the card up here. If it's the audio, you can just go back to the last episode. Yeah. So Elijah is back. It needs no introduction anymore because he and me just no more. And on this episode, it's unscripted, and we'll make Elijah pick a dev topic, a technology topic of his choice, and talk about it for 15 minutes. I may ask questions in between if I do, but if not, you'll just click on it for 15 minutes. And your time starts in 5, 4, 3, 2, 1. You got it.
Wow, 15 minutes. I did not know that. Okay. So I'll be talking about Go. I'll be talking about Golang and APIs in Go, development in Go, deployment in Go. Right. So for those who don't know, Golang is a language that was originally designed at Google by a team of engineers who had worked on a few other languages in the past. One name comes to my mind as Rob Pike, but I know that there were a lot more members of the team that worked on Go. Really, really great guys with a lot of experience in other languages. Now, the language is designed in 2009. That was when so right now it's about 11 years old. The main reason for the design of Go, I mean, before Golang, the software engineers at Google were mostly writing. I think they were mostly writing in Java, but they were using C for some other critical components. So the issue with all that is Google wanted a language that just had concurrency as a first class feature, right? Because these days we have a lot of we have a lot of multiprocessors, we have a lot more powerful computers and languages, and Google basically needed a language that would take advantage of all those features and build really powerful applications. So Golang is a language with extremely fast compilation times. That's one of the good things about it. That concurrency as a first class feature, which is really good. And then it compiles to really small binary sizes. And so these are just some of the things that I like about Golang. Right now, Go is mostly used in cloud engineering. So you're going to see a lot of all these cloud resources, Kubernetes, Docker. So I mean, these are just two technologies mostly used in container technologies, and you're going to see that they are written in Go. Now, there are lots of other other container technologies written in Go. If for example, if you go to the CNCF projects page, the CNCF is the Cloud Native Computing Foundation. You're going to see a lot of all these projects. You're going to see etcd, Core DNS, and a lot of them are written in Golang because it just works really well for those kinds of applications. Now, Go is really easy to learn. For me, I mean, when I started learning Go, I'd already been coding for, that was 2018, so I've been coding for like 3 years at that point, and I'd used Python a lot. So when I started with Golang, I just thought it was really close to Python for me. I mean, Go was influenced by a lot of languages, Smalltalk, Python. You're gonna see it's a pretty huge list, but the one that I knew a lot before I learned Go was Python, and it was just like the syntax was a bit close for me, the way you loop, some of those things, and I thought it was even much more simpler than Python was to learn, because that was also one of the things that the Golang team decided to keep things pretty simple and not provide like 6 ways of doing something. You want the loop. There's just one way. You're not gonna do for a for loop, for off, for in, or object stuff for H, or all those things. You're not gonna have all that. So these are just some of the things that the Golang team decided to do. So it's really simple. You don't really have a lot to learn. I mean, if you just go through the Golang tutorials, for example, the official talk, and then you read the specifications, at that point you'll be pretty good to go. But for me, when I started out, I also used an online resource called goforsciences.com. So there are a couple of like over 20 exercises where you're going to be where you get to build something. So there's a problem statement, and then you build something in Go, and then the problem author solves gives the solution to the problem, and then you can just compare it with what you came up with and see if there's an approach. And sometimes it does like 2 different solutions for the same problem. So that was a very good result for me when I was starting out with Go. Then I used it on a few projects at the time, and then a few months after I picked it up, I'd already been contributing to some open source projects in Go because it was just so easy to do that. Let's say you're working with a library now, and the thing about Go libraries that makes them really different from others is that the library is going to be on your computer almost exactly the same way as it is in GitHub or whatever source repository. So I mean, so let's say you're working with a package now, you imported it, and then there's a function in there that you use it. But you just click to the source, and then you feel like there's a function you need that the package doesn't give you. And usually packages are really light in Go. Just like it's rare to see a Golang package that has dozens of files. Usually you just see one source file and a test file for the most popular packages, just 2 Go files, and that's it. Then a README file. But some of them, of course, you have a few dozen and so on. But those are really rare. So you're just going to go into the Golang source file. And for me, I would just add like something that I wanted to do that's really simple, just a minor change. So I just open a PR against the package, and then just put it in there, just a simple function. And usually it gets matched, or if there's so the experience was just really good for me because up to that point, I didn't really have a lot of experience with open source development. But I had done some things in PHP before that. I had a Symfony module, I had a Drupal module, just were in PHP. But just being able to contribute to some of these libraries was just really good. And then that was the point where I started looking at Kubernetes. So when you talk about Golang, I think Kubernetes right now is basically the biggest project, the biggest open source project written in Go. The ecosystem is really huge. The community is vibrant. Things move really fast in the Kubernetes community. So I had my eyes on Google Summer of Code because at that point I was in my final year. So I wanted to participate in Google Summer of Code with Kubernetes. So I started contributing to Kubernetes. I had some mentors there that could really help me out with it. Any users I had. So that just happened. Google Summer of Code came on. I got in. Then I contributed to the Kubernetes dashboard project. And then from there, I got a job with Reflex. Reflex is a company that provides Kubernetes monitoring and Kubernetes cost management and monitoring. And basically, from there, most of my day job just revolves around writing Go code every day. Now, Go, I mean, as you can probably tell, I really love the language. It's easy to develop things in Go. It's easy to write tests for functions.
Just like C# for me.
Yeah, sure. You've been on that one for years, right? No, I mean, C# is really good. Yeah. I did some C# myself, and just a little bit, maybe like 5% of what you did, or like 2% or less, but something like that. Just check that the syntax, and it's really nice. Now Go, I mean, really love the language. The the team is really nice, and you you just feel like I mean, let's say you're looking for a package, and then you in Node.js, for example, then you see something that was written maybe in 2016. Immediately you're gonna be like, oh wow, there's no way that this isn't broken yet. Maybe some of the other dependencies are
Appreciated, or it's not secure enough.
exactly. But we go, you see a package in 2016, maybe 2 or 3 source files. The code is tight. I mean, if you look at it with today's eyes, you won't see anything there that shouldn't be written as it is. Like maybe there's a new language feature that you can take advantage of. The language doesn't change that much, and that stability helps maintain a good amount of backward compatibility, and the language doesn't do too much. But then again, you writing in Go, you don't really have to invent a lot of other things yourself. So that's why packages are kept really light and work really well. Compilation is really fast. Kubernetes, for example, you have thousands of source files. I'm pretty sure there will be over 1 million Go code in the Kubernetes repository. But if you try to compile one of the Kubernetes binaries now, for example, kubectl, in less than a minute, the compilation is done, and you have a binary that you can run. So for small projects or for hundreds of thousands of lines, less than a minute, you have it there. And so same thing for the test that you write. They don't take ages to run. Same thing, your images, for example, if you're using a Docker image with Go, you're just gonna have a single binary in from Docker's Scratch or Distroless by JCR. You just have one of those base images, and you have an image size that is really light and starts up in seconds when you deploy it to whatever environment you're using. So these are just some of the things that I really like about Golang. Easy to learn. The type system is really nice as well. So it's strongly typed, and that's something that is really good. Once Go compiles, then whatever errors that might begin there are going to be errors of logic, but you're not going to have something sneaking up on you at runtime, for example, usually. But sometimes this happens, especially with memory leaks, where maybe you're referencing a pointer that's new, that doesn't exist. You're trying to access a memory location that doesn't exist. So those happen. But of course, there are safeguards in place to prevent all those if you code in really tight.
I think a question I will have is how does Go manage garbage collection?
Right. I don't actually know much of the internal details though, but I know that Go handles. I know that it's garbage collected, so it does that. But I just don't know the specifics of providers. Yeah, I don't know.
Okay, maybe I'll give it a try.
Yeah.
When I decide to retire.
Okay. So yeah, it's born, right?
So I actually tried my hands on it about I think 2 months ago or so. I just wrote a simple hello world programming, and it was pretty neat. So the only reason I didn't continue in it was I had a lot of projects that was running .NET, and I just couldn't make that. But of course, if I have a good developer that I could hire to write stuff for me, well, I'm good. It should actually make me understand it more. Having someone writing for me than me going through the code and seeing stuff like that. Okay, so now, if someone was to try to learn Go today, where would you tell them to go?
Go for sizes, right? I'm just gonna say that first look at the core of Go. So that's core.golang.org. So you're going to see just a few pages that you can just see the syntax. Then go for sizes.com. So just pick 2 or 3 of the exercises and solve them. And at that point, you're going to have a pretty good grasp of exactly what the language is supposed to do. Just a few months ago, I was talking to someone who had never written a single line of Go. And within 3 weeks, she already had a PR open against the Kubernetes repository. So that was no, I'm not kidding you. So that was pretty good. Yeah, all she wrote before then was I think it was just notes. on Python or so. But so that's so you can just do that easily. So that was just what I said. Thought of Go and then Go sizes. Then you can just go do whatever it is that you want to.
Right. That's awesome. And that's 15 minutes of Go. We actually clocked 15 minutes. Yeah, about 15 minutes, 30 seconds there about now. We're good.
Yeah.
I think I will start adopting this method. 15 minutes talk about your tech.
Did you just start? Did you just experiment with me or what?
Well, the 15 minutes experiment, yes. The topic experiment also, yes. Because before I had already told the guests what they would talk about. For example, Lawrence, we already decided, okay, we're gonna talk about this. I actually had the topics in my head, but what I tried to do, I just do this. We talk about.
Okay.
Yes. Pretty chill, cool. Experimenting all the time. Debugging in production.
Yeah, sure. You're gonna have a crash in production one day. I'm not praying for it, but I'm praying for it. I'm praying it doesn't happen. Yeah.
It won't happen.
Okay.
Fire. Alright, so thanks very much, Elijah, for sharing your time with us, talking about Go on the unscripted part of This Dev Life. So, listeners, if you've not been listening to This Dev Life before and this is your first episode, please go ahead and follow it on your favorite podcast platform. We are available on Apple Podcasts, Google Podcasts, Spotify, Breaker FM, and of course, you can go to my website, Oladapo.com/thisdevlife to get the most recent episodes and go through them. So, that's it. Any final words for us, Elijah, before we call it a day?
Yeah, I mean, try to have fun. The times are crazy now with the pandemic and so on. So, try to relax. Don't get too bored. Don't lose your mind. Everything is gonna be good soon. That's just it. Yeah. Right over.
So thanks very much, listeners, for listening to this episode of This Dev Life. We'll catch you again on the next time.
Peace out.
Say bye.
Bye.
Right. Bye everyone.